All right, so I want to write the electron dot symbol for these different atoms. I've got sulfur, boron, and chlorine. And hopefully by now you figured out kind of a trick to finding the valence electrons. Essentially, this column number right here tells you how many valence electrons we're dealing with. So 1 valence electron for anything here, 2 valence electrons for here, 3, 4, 5, 6, 7, and 8 or 0 for that matter. It's kind of, I guess it's kind of unclear as far as, yeah, I guess there's 8 valence electrons, but I kind of like to consider it 0 because that way I know that it's happy, it's full, and it doesn't need anything else. Anyway, so what was I dealing with? Sulfur, right? Sulfur has a, it's right here, 16, and that has 6 valence electrons. So let me just draw it out for you. Sulfur. The way that we do it by convention in, and not everybody does this, but the way this book likes to do it is they put 2 dots here, so that covers the 1, 2, and then we need 6 of them. So I'm going to go 3, and I'm just going to kind of go clockwise. 4, 5, 6, and each side of the element can hold up to 2 because essentially you want 8 dots on the outside. Now, like for example, argon has 8 valence electrons, and so it's got everything that's full on the outside. Sulfur has, it has 6 valence electrons, so that's how that looks. For boron, let's see, doing our lazy way of doing it, boron's 5. It has 3 valence electrons. We can kind of look at that straight off. And so boron looks like this. It's got 1, 2, and then a third one. You start up at the top. Now chlorine. Okay, chlorine looks like this. Chlorine, Cl. That has 7 valence electrons. But notice how they said the word anion. An anion is an ion that is negatively charged. Now the way that we think about that is this has 7 valence electrons. So it's 1, 2, 3, 4, 5, 6, 7. And that's what chlorine normally has. But a chlorine anion is, see, chlorine is desperate. It really, really, really wants to grab an extra electron. Because if it had an extra electron, it would be more like argon. And if it was more like argon, it would be happy. Because argon, this cool guy over here, has 8 electrons on the outermost shell. Whereas chlorine desperately, he's like so close to being argon that he can't stand it. So he's going to go off and steal an extra electron for himself because that would make 8 on the outermost shell. So he creates a chlorine anion, which is a Cl with a minus on it because he has an extra electron. And that extra electron we can account for in this drawing, this Lewis dot structure drawing right here, and put a dot down there. But we also might want to indicate that we messed with that a little bit and we have a negative charge tacked onto there. Anyway, this is what chlorine is, even though that doesn't represent the number of protons it has because it only has, I mean, if I were to only talk about a neutral atom, I wouldn't add that extra dot on there. But since I'm talking about an ion that has an extra electron, then it has that extra dot that we tack onto there. That's how you do the electron dot configuration for those kinds of things.